The purpose of this little lecture is to go over electron configuration, try to relate it to the activity you did with the electron boarding house or hotel. So if we go back and rethink the electron boarding house, the goal was to see occupancy over time and relate it to a code. And what this was supposed to do was to get you ready to think about where electrons would be in an atom. So what you saw with this activity was different levels of the boarding house or hotel were filled up in certain order, and certain bunks were filled up in a certain order, and it related to a code using some numbers, letters, and exponents. Actually, the reason we had you do this was it represents where electrons are located and how the electrons fill these areas called orbitals. For your analogy, or for the hotel, the floors were a lot like the energy levels in an atom. We had energy levels 1, 2, 3, for example. The rooms represent sub-levels in the atom. And in the atom, the sub-levels are designated by letters, S, P, D, and F. Your example used just S and P to get you started on that. The bunks in your activity represent the orbitals in the sublevels where the electrons are located. You had this little rule going where one bunk would occupy two people, and so it was like the atom where we have two electrons occupy an orbital. And as you went through the hotel or boarding house, you probably figured out these rules, that every room had to have bunk beds. You didn't have single beds in the rooms. And this is a lot like Pauli discovered with the atom, only two electrons occupy an orbital and they have opposite spins. We're going to see how that is designated with some symbols and diagrams. Off-ball. Off-ball claimed that electrons enter the orbitals in the lowest energy levels first. This is a lot like in the hotel where you filled the bottom floors first before the upper floors. Finally, there was a scientist, Hund, who said that electron orbitals fill up half first and then they pair up and they have opposite spins. This was a lot like the hotel where you filled the bunks in a sublevel first before you paired up people in the bunks. Let's take a look at the diagram. So going from the bottom to the top, you should have seen that we always fill up the 1s level first, and then the 2s or sunny level was filled up. And in these diagrams, sodium, aluminum, phosphorus, all of these are filled with two people in the motel. The double arrows, the arrows pointing in opposite directions, would symbolize the different electrons with opposite spins. We have our 2p levels all filled. Let's take a look at sodium. Sodium has a total of 11 electrons. So our 11th electron goes up to the 3s level because that's the next highest energy level. For our aluminum, we have 13 electrons, so the 3s level is totally filled up first before we go up to the 3p level. Going to the last example, phosphorus. Phosphorus is different than aluminum because we not only have the 3s full, we have 3 electrons in the 3p level and they first are put in singly before they are paired up. So that's why those 3 last highest energy level electrons are by themselves. And you can see how we symbolize the occupancy at each level with the code. When we write something like 1s1, 2s2, whatever, the first number symbolizes the energy level of the atom. The second letter is the type of orbital, and again I said there were S, P, D, and F. The exponent represents how many electrons are in that particular orbital. Another thing that you're going to see is diagrams like this. Instead of making full boxes, sometimes you're given a stair-step diagram and you can just go up the steps and fill in the electrons as each level would be filled up. And that's kind of helpful, and I'll make those available to use on your homework. These are three-dimensional pictures represent the orbitals. At the top, the red is an s orbital. The next one are the p orbitals, the 3p orbitals. This diagram gets a little more complicated into the d and f orbitals. But the reason I'm showing you this is so that you get an idea that an orbital is a three-dimensional area in space where there's a high probability of finding electrons in those particular orbitals, according to how many electrons are in the atom. Another way that you can do this is by starting to practice your arrows. For carbon, carbon has 6 electrons. So you would do 2 electrons with opposite spins in 1s and 2s. The last 2 electrons, again the p orbitals, are occupied singly first. So this is what an electron diagram would look like for carbon. The way you would write this would be 1s2, 2s2, and then 2p2. So let's take a look. Maybe you want to pause this and say, could I do this for magnesium? So if you wish, pause the recording and try magnesium. If you got it right, this is how we do magnesium. Our 1s, 2s, 2p would all be filled with opposite pointing arrows, and then the 3s would also be full. Finally, your homework is going to ask you to go backwards and forwards using the symbolism and the diagrams. What element would this be? Well, the easiest way would be to add up the total number of electrons, which is the sum of the exponents. If you add this up and look at your periodic chart, you should find that this is silicon. Another question that comes up in the homework, how many electrons are in the highest energy level? The highest energy level is the 3rd level, so you would take the 2 electrons and add them up. So that would be 4 electrons occupying the 3rd energy level. So that should get you introduced to electron configuration enough to do the homework on Kia.